Let's do this problem right here. The question is asking, the first question is find the determinant A. So let's see how we can find it. Okay, here we go. So I'm doing the A part. So A part is determinant A. So what I have to do is, I have to pick up this matrix right here, 1 minus 1 minus 1 1 0 1 0 1 3. So in this case we simply put plus minus plus, and then we take this number. So if we take this, so determinant A is going to be, if I take this number, I have to eliminate all the vertical and horizontal of this one. So if I eliminate AD minus, now I have to do the AD minus BC. AD minus BC, AD is going to be 0 because 0 times 3 is 0, and minus BC is BC is going to be 1, but this is minus 1 because minus BC, so minus 1, and then minus 1 is going to be plus 1, and if I take this one, I have to eliminate all the vertical and horizontal. So this is going to be 1 times 3, 0 times 1 is going to be just 3. Then we have the last one, it's going to be minus 1, and if I take this one, I have to eliminate this component, vertical and horizontal of this one. So it's going to be 1 times 1 and 0 times 0, so it's going to be just 1. So if I calculate this one comes out to be minus 1 plus 3 minus 1. Therefore, this is equal to 1. So determinant of A is equal to 1. So that's the answer for the first question. And for the second question, they are asking, find A inverse using the cofactor method. So we have to know the cofactor method equation. The equation is A inverse is equal to, A inverse is equal to 1 over determinant A multiplied by cofactor A transpose. So this is the equation to find the A inverse using cofactor method. So we know the determinant A already, but we have to find the cofactor. To find the cofactor, I have to take every single number. So first of all, I'm doing the cofactor 1 1. So it's first row, first column. See this one. I'm picking this one. So it's like same like the determinant we did. So 1 1 means I add this number here, 1 plus 1. And now what I have to do is I have to eliminate all the vertical horizontal component, and I have to do the AD minus BC. So if I do that, I will get minus 1 right here, minus 1, and it's going to be itself because when and also one more thing, if it's if you add them together, if it gets an even number, it means the value is going to be same. If it's an odd number, the value the sign is going to change. For example, if we get 1 plus 2 here, this will become positive, right? Because I'm multiplying this one by a negative, and this will change the sign. So whenever we hit even number, we don't have to worry about anything because it's going to be the same number. So cofactor 1 1. So I had to do for the entire thing. So let's do this cofactor 1 2. This is going to be minus 1 1 2. Then if I take this one, I have to eliminate 1 times 3. That's going to be 3, and here the sign is going to change because the odd number. So minus 3 cofactor. So it just goes on and on like this. I just put the numbers right here. So cofactor 1 3, if you calculate 1, cofactor 2 1, if you calculate that comes out to be plus 2. Then cofactor 2 2, it comes out to be 3, cofactor 2 3 minus 1, cofactor 3 1 minus 1, then cofactor 3 2, this minus 2, cofactor 3 3 is equal to 1. So now we done all the things, all the cofactors. So you do the same thing like for this one, minus 1 power 1 plus 3, 2 plus 1, then you add you eliminate whatever the value components, and you find the determinant kind of thing, AD minus BC. So if you do that, you will get all these values. Now we have to arrange exactly the same order. So want to see first row, first column, first row, second column. I have to arrange in the same order. -1, -3, 1, 2, 3, -1, -1, -2, 1. So this is equal to cofactor A, but we want cofactor A transpose. So in this case, to find the cofactor A transpose, what's going to happen is first row will become first column, second row will become second column, third row will become third column. So that's how it's done. So let's switch this one into columns. So it's going to be -1, -3, 1. Then we are going to get 2, 3, -1, -1, -2, 1. So this is cofactor A transpose. Cofactor A transpose. Now we have found the cofactor A transpose, and we found the determinant is equal to 1. So this is 1 over 1. So basically it's nothing. It's just going to be 1, right? Therefore, cofactor A transpose is going to be equal to the A inverse. Therefore, we can say, I will put this one right here. So it's going to be -1, 2, -1, -3, 3, -2, 1, -1, 1. And if you multiply this one by 1, what's you going to get? You're going to get the same number. Therefore, we can say A inverse is equal to, so the final answer is -1, 2, -1, -3, 3, -2, then 1, -1, 1. So this is my final answer. And now let's move to the next question. So I erased this whole thing. Okay. So let's move to the next question. The next question is about Cramer rule. Use Cramer rules to solve the x2 only in the system Ax equal to b, where b is given. So to find the x2, what I have to do is determinant of x2. So this column is x1, this column is x2, this column is x3. So I had to put this b value in the x2 to find the x2. For example, if they ask x1, I have to put this b value in the x1 column and find the determinant on top. In the bottom is going to be the original form of determinant that we found already. That's 1. So let's do this one. So if I do this, now we are doing for the x2. First column is going to be the same, 1, 1, 0. Second column I plug this value because that's what you have to find, the x2. -4, 4, 11. And in the third column we are going to have same number as this one. So this is going to be -1, 1, 3. And in the bottom we found it already. Let's say determinant A, that's going to be just 1. So the top determinant is going to be the final value, because bottom we are dividing it by 1, so it doesn't change anything. So in this case, if I take plus minus plus, so if I take this one, what's going to happen? AD minus BC, 12 minus 11 is going to be 1. Then if I take the -4, this is minus sign, right? Minus 4 is going to be +4. +4, and if I take AD minus BC, 1 times 3, 3, 0 times 1, 0, so it's going to be just 3. Then the last one is -1. If I eliminate all the components, it's going to be 1 times 11. 11 minus 0 is going to be 11. Therefore, the top part is going to be, so bottom part we can put 1, because determinant A we found out already is 1. And then here in the top we are going to have 1 plus 12 minus 11 over 1. Therefore, if you solve this one, 12 minus 11 is going to be 1, 1 plus 1 is going to be 2. Therefore, x2 is equal to 2 is the final answer for that question. And that's how it's done. I hope you guys like this video. See you next time.